Problem F17-17, a spool has a radius of gyration about center of mass of kg equals 300. The couple moment is applied to the spool and the coefficient of friction between the spool and the ground is 0.2. Determine the angular acceleration of the spool, the acceleration of g, and the tension of the cable. So we have this moment driving this cable to, and obviously it's slipping at the bottom, to roll towards B. So free body diagram, we got mg down. Let's do this over here. Here's our spool. Here's our spool. We got tension of the rope over, mg down. We got normal up. We got friction pushing back as the spool rolls this way. Okay, so if we sum the forces in the y direction, we can find that the normal minus mg is equal to 0, as it's not accelerating up or down. So the normal equals mg, which equals 200 times 9.81, which equals 1962 newtons. So the force of friction then is equal to the normal times mu, which is 1962 times 0.2, and we get 392.4 newtons. Now summing the forces in the x direction, we get negative, we get friction, the force of friction in the negative direction, plus the tension, and that is going to be equal to the mass times the acceleration. Those are the only two forces in the x direction. So negative 392.4 plus the tension, which we don't know, is equal to the mass 200 times the acceleration. Obviously we have two unknowns, so let's go on to write the moment equation. Summing the moments about g. Okay, here's the center. So we have t causing a negative rotation times this distance, 0.4, minus friction. The force of friction is pushing this way. That's also causing a negative rotation that direction. So that's minus the force of friction times 0.6. The radius there is 0.6, plus the motor that's driving it, or whatever, 450. That's a positive rotation, and that will all equal I alpha. They don't give us I, they give us K. I is equal to the mass times K squared, so that's 200 times 0.3, converting to meters, squared, which is 18. So let's put in, so we got negative 0.4 t minus 392.4 times 0.6 plus 450 equals 18 alpha. Combining this, we have negative 0.4 t plus 215 equals 18 alpha. So we have this equation with t and alpha and this equation with t and a. Well, we can equate alpha and a by the radius because t is not slipping, right? It's rolling up that cable. So a equals alpha r, where r is 0.4. So a is equal to 0.4 alpha. Let's put this 0.4 alpha into this equation right there. Now we have negative 392.4 plus t equals 200 times 0.4 alpha. So t is equal to 80 alpha plus 392.4. Putting that into this equation for t, we get negative 0.4 times 80 alpha plus 392.4 plus 215 equals 18 alpha. Simplifying a little bit, we have negative 32 alpha plus 58.04 equals 18 alpha. Therefore, alpha equals 1.16. And putting that into there, then A is equal to 0.4 times 1.16, or 0.464 radians per second squared, meters per second squared, and t then is equal to, putting alpha there, 80 times 1.16 plus 392.4, and t equals 485 newtons.